Hello, everyone. I am Yanqi from Sigma, the Food Safety and Quality Group, where we offer the full analytical workflow and the solutions for all kinds of food safety, quality, contaminant, and component analysis. Today, we are presenting a work we collaborated with Shimadzu Scientific Instruments, the determination of heavy metals contents in baby foods, including apple juice, puffs, and rice cereals. So heavy metals, including cadmium, mercury, arsenic, and lead, are known to be very toxic to human beings. Exposure to heavy metals, especially at an early age, could pose kinds of health issues. However, heavy metals are routinely found in different food metrics due to their presence in the nature environment, from where they find their ways into the raw materials, packaging materials, and the food production process. Recently, a report issued by the U.S. House of Representatives in February 2021 showed that six major baby food brands to have elevated big four heavy metals concentration in their products. So, in response to public concerns and the legal interest, the FDA announced their Closer to Zero action plan in the summer of 2021, outlining their steps and intentions to add further limits to baby food commodities based on scientific evidence. This program examines current levels of heavy metals in commercially available baby food, assesses the potential risks from toxic metals, and sets standards and guidance for baby food producers to help ensure that baby foods have safe levels of heavy metals. The program also examines opportunities to phase out certain known commodities that may be prone to higher levels of heavy metals, such as rice or certain starch-based food. Additionally, action included the proposed congressional bill, the Baby Food Safety Act of 2021, which postulates the recommendations for regulators and the baby food industry to eliminate toxic compound in baby food. With increasing concerns about heavy metals in baby foods, Sigma and Shimadzu worked together to develop a comprehensive ICP-MS workflow to determine the concentrations of big four heavy metals in selected baby foods at very low limit range that are shown in the table 1 on the left corner of the poster. So to achieve optimal measurement sensitivity in a trace level detection by the SAPMS, the choice of reagents and standards for sample preparation is actually very critical, since ICP-MS requires high purity of reagents and samples for an accurate detection. So therefore, Sigma's super pure and ultra pure high purity reagents are being used to be compatible with the detection levels of the target heavy metals and to meet instrument requirements to ensure optimal ICP-MS performance. Additionally, this work is also aiming to provide guidance on selecting other sample preparation and workflow products for the heavy metal analysis. So referencing to the AOAC method, heavy metals in food, approximately zero point 0.5 grams of each sample were weighed into a sealed Teflon reaction vessel that contained 4.5 mils of 60% ultra-pure nitric acid and zero point 0.5 mil of 30% ultra-pure uh, hydrochloric acid. The sample was placed in the fume hood for 15 minutes for the pre-digestion and then digested further with a microwave digestion system using its program to heat hood, ramp-up time of 20 minutes to 210 degrees Celsius, and hold time of 15 minutes before cooling down. A blank sample consisting of only the reagents were also prepared as a control, as were for fortified samples by spiking the tracer certified reference material containing arsenic, cadmium, lead, mercury, or heavy metal mix. Reference standards were all packed and pre-dissolved in 12% nitric acid to minimize any contamination during the sample preparation or the weighing process. Digested samples were diluted with the ultra-pure water down to 4.5% nitric acid and 0.5% hydrochloric acid content, and filtrated with Milex Durapore PVDF syringe filters. The size we're using is a 0.45 micrometer pore size and 33 millimeter diameter to remove the impurities and to avoid any elemental contamination. And to be noted, PVDF is selected because of its very strong acid tolerance. So tracer CRMs, scandium, indium, and bismuth were also selected as internal standard elements and added to the calibration standards in the samples through an internal standard automation addition kit. So for the instrumentation, all diluted samples were analyzed with a Shimadzu ICP-MS 2030 coupled with a SATEC ASX 280 autosampler. Reference samples including initial calibration verification standards, continuing calibration verification standards, a method blank, and the matrix spiked samples containing the tracer CRMs were run actually to ensure the validation of the calibration curve and the precision of the quantification. Calibration curves for four target heavy metal elements are shown in Figure 1. All calibration curves were determined using tracer reference materials, and all of them actually show excellent linearity across the respective calibration range, with the coefficient of determination that is also shown in Table 2. After the digestion step with ultra-pure high-purity acids and the filtration step with the Milex dual-pore PVDF syringe filters, all baby food samples were completely decomposed, leaving a very clear solutions for the analysis. And in Table 3, it shows the concentration of heavy metals in the digested solutions of the blank sample, the original baby food samples, and the fortified baby food samples. So in the blank sample, which is only containing the ultra-pure high purity reagents, no targeted heavy metal elements were detected, which suggests the trace level of the ultra-pure high purity reagents lies below the limits of detection of the ICP-MS instrument. Thus, any interference from the reagent is well controlled for heavy metal analysis. And all relative standard deviation were below or at 5, which is indicating a high precision when using the tracer CRMs with the ICP-MS instrument. Additionally, all samples, including the blank, the original samples, and the fortified samples, and the calibration verification samples, showed recoveries in a range from 90% to 110%, again suggesting that tracer CRM can provide reliability and accuracy to the methodology and to Shimadzu ICP-MS 2030 measurements. And in Table 4, it shows the calculated concentrations of the target heavy metal elements in the original samples without any digestion, taking into account the dilution factor and the initial mass of the matrix. All apple juice, puffs, and rice cereals are detected the presence of arsenic and lead. Cadmium and mercury were detected in some of the baby food samples. In a side note, the content of arsenic detected in rice cereal and puff, which are uh, 105 ppb and 124 ppb respectively, were noticeably higher than the action levels proposed by the Baby Food Act and the FDA's closer to zero plan for heavy metals in baby food. So as a conclusion, Millipore Sigma's tracers, CRMs, ultra-pure high-purity reagents, and Milex dual-pore PVDF surge filters provided excellent reliability and do not noticeably interfere the sample digestion and sample preparation for the whole study. Thus, they ensure the precision, accuracy, and sensitivity in ICP-MS instrumental analysis of heavy metals in the baby foods. On the right corner of the poster, we actually provided a product list for all the products are being used in the study. So if you are interested in any of those or you want to learn more about the method development, feel free to either contact me through the email address we provided on the poster or go to the sigmaaldrich.com to learn more about this study. We do have a application note that's available online and also a brochure to tell you more details about all the products that we're offering for heavy metal analysis. Thank you very much.